Good afternoon once again. So we were discussing the brick lintels. So here bricks are arranged in the vertical manner, edge to edge. So remember the word here we call it as this type of arrangement. One brick, second brick, third brick like this. These are called as edge to edge construction or keeping. So here in the isometric view you have seen for every brick on the surface there is a depression. We call it as a frog. So that frog will act as what? Will act as a key or a binding for the next one. Binding for the next one. So this brick is kept in vertical direction in this way. So in which place frog will come? Exactly here. So there will be frog here, there will be frog here. So every brick will containing frog, no? So here also frog, here also frog. So each frog will join this and this brick. Each frog will join this and this brick and it will act as one single unit. Okay. So the provision of frog on the surface of the brick is very very important on the surface. So each brick on the edge to edge such that their vertical surfaces will have frog and that frog using mortar filling. So later on after arrangement you are placing mortar, no? After that they are going to put mortar. So that mortar after getting hard it will give one proper functioning lintel. One functioning lintel. Now this is normal brick and one another word what is that? So this type of joints, these are called as joggled joint. So in the module 2 stone joints, so that is the type of joints we have discussed. Please refer it back. What are the joggle joints? So I hope it is clear now. Brick lintels. So here these are used for smaller spans or the less distance or the less load. Suppose you want to use brick itself in the construction of lintel, but load is little bit larger and span is also little bit larger. Then you can go for reinforced brick lintel. You can go for reinforced brick lintel. I will just enlarge this portion. What are the main points here? Reinforcement means what? The same construction, but you are using what? Some reinforcement bars at the bottom, some reinforcement bars which are there in the vertical portion, some vertical portion. So I will try to enlarge this one a little bit more. Okay. So I hope you have understood what are the steel bars. What are the steel bars? So I will draw it in the green line. So there is a brick. So this is the elevation, but when you see it in the cross section, how many bricks you can see? How many columns of the bricks? So here only you can see front face of the this one, but the thickness may include one brick, two brick, three brick, may include three bricks. So for each three bricks, there is a gap, no? After each and every brick, there is small gap. So in that small gap, you are putting what? Steel bars. Very important. These are the steel bars. So in the section, these things are appearing as dots, but in the longitudinal section, these dots will appear as this line. I hope it is now clear. Very engineering this one. Okay, I hope everyone is engineering student now only. So in the cross section, if it is a dot, but in the elevation, it is appearing as a line. I hope this should not be a difficult one to understand. Okay. So the similarly, so this horizontal bars which are inserted between the bricks, okay, in this fashion are called as main bars. These are called as main bars or main reinforcement. I repeat, the dots in the section, the straight line, horizontal line, okay, these are called as main steel, main bar. Why it is called as main? Whatever the load is coming on the top, so it is going to resist. It is going to resist or support the brick. It is going to support the brick. So that is why we call it as main bar. Another bars is there. What is that? Between the every vertical joint you are giving some vertical bars. You are giving some vertical bars. So these vertical bars in the section also appears like this. It is appearing like this. Okay, one continuous vertical bar structure, it is appearing like this. Okay, I hope it is clear. Okay, what is this? So here one vertical bar, but when you see the cross section, it is throughout this one. Where is, what is that? This one, no? Okay, like this it is going full circumference. So this type of bars are called as stirrups. These are called as stirrups. So these stirrups will provide shear strength. I hope it is clear. Main steel is providing bending strength. Means what? It is not going to failure in bending. It is not going to allow this lintel to fail in the bending. But stirrups will provide or rigidity, it will give rigidity for the shear. Means what? That is why these are called as stirrups. Okay, shear means what? Cutting means what? This will go down, this will go up, like this. The sliding is going to takes place between the bricks, no? So in the previous one we have studied. Okay, remember those points. So to control that one, this shearing of the force, shearing of the bricks, like this, one is going up, one is going down. So to avoid that one, to give more rigidity, we are providing stirrups. Now, what is the point here? Bricks are there. You are providing main steel in the horizontal direction. What is this small line? Huh. This is this is called as a cranking of the bar. This is called as cranking. Cranking means what? The same horizontal bar is bent near the supports. This is the support, no? This is one support, this is another support. What is happening in cranking? Cranking means the longitudinal bar or the main bars nearer the support, they are bent upward like this. So this bar is moved here and made to bend upward and again go back here. So this type is called as cranking of the bars. These are called as cranking of the bar. It will give more stability. Okay. So generally 8 to 10 mm dia bars are used. Okay, 8 to 10 mm dia bars are used. So we will see in the text portion what is this. Reinforced brick lintel. We will go fast. No, there is already explained. No. Okay. So reinforced brick lintel. So I just told, no, when loads are heavy and the span is more, so maybe it will go to reinforcement. So we can go for reinforcement. So the generally depth, what is that depth? Depth is kept 10 centimeter or multiples of 10 centimeter. Multiples of 10 centimeter. Why it is like this? I will go to this diagram. So depth, what is that depth of the lintel? This distance. I have told you, no, this distance is the depth. This distance is the depth. Why it is kept 10 or multiple of 10? Multiple of 10 because brick size is itself 10 by 10 by 20. So to have a uniformity in bricks, to have a uniformity in the construction, so generally they are taken 10 centimeter or multiples of 10 centimeters. Okay. What is the third point? I hope it is already explained. If the depth is 15 centimeter, then 5 centimeter thick tiles are used. It's not so important. You just remember this point. So why it is not so important? Okay. So generally these are used for smaller spans. Smaller spans. So 10 or multiple of 10s are used. Generally, if the 15 centimeter brick are used or depth is used, then 5 centimeter thick tiles are also used. Okay, 5 centimeter tiles are used. How is the combination? Total depth is 15 centimeter. Up to 10 brick is used. Up to 10 brick and remaining 5. Remaining 5 is tile. Remaining tile. Remaining 5 centimeter is tile. That's all. 1, 2, 3. Alternative bricks can be placed on the edges. Very important. So it is placed in the edges side. Edge side. Now what is that? Bricks are so arranged that 2 to 3 centimeter space is left in the lengthwise between the adjacent bricks for the insertion of reinforcement. Where is that 2 to 3 centimeter? Go to this diagram. Yes. So this subject requires explanation in this way only. You need to have reference with the diagrams continuously. Then only you will understand. So this is the that 2 to 3 centimeter. Here that gap is there. So I cannot enlarge much. Okay. 2 to 3 centimeter gap here. 2 to 3 centimeter gap here. Between what? Adjacent bricks. Between adjacent bricks. So I will make like this. One brick, 2 brick, 3 brick. Okay, it is not up to the scale. So this gap is 2 to 3 centimeter gap. So in between you are going to put reinforcement like this. You are going to put reinforcement. So that is shown here. That is shown in this diagram. I hope now it is clear. So 2 to 3 centimeter gap between the adjacent bricks to insert the main steel. That's all. Okay. Yes. So what is this next? So whatever the joint is there, no? So the gap or joint, it is filled with 1:3 mortar. Okay. That gap is there. Where is that gap? Yes, here, this gap. Whatever the gap is there, you are going to put using mortar. Okay. Now next is what? Vertical stirrups of 6 mm dia and main stirrups of 8 mm dia, okay, which are cranked at the ends. So this point I have already explained here in the when I was showing the diagrams. So here, so vertical stirrups means what are the vertical stirrups? This so general dia, so dia of these bars are 6, okay. So this horizontal bars which are cranked near the supports, cranked near the supports, so those things are appearing like this. This dia is 8 to 10 mm dia. Okay. I hope this reinforced brick lintel is clear now. Yes. Next is reinforced cement lintel, that was brick. Here total concrete itself you are using. Here what if you enlarge this portion, it is made up of concrete only. So that is why they are called as RCC, reinforced cement concrete lintel. What they are doing? First they provide centering, shuttering support here. After that they will give formwork. After that they will put the formwork. Okay. Formwork like this, casing work, formwork they will give. After that they will place the steel bars, this steel bars, this stirrups, everything they are going to place. When everything is fixed, when everything is fixed, they are going to put the concrete, or they are going to pour the concrete, and they will make it spread equally, distributed equally, and they will compact, and they will leave for 20 days. For what? Curing purpose. For curing purpose. After the curing, it will be sufficiently strong and it will be taken. What will be taken? This centering and this formwork is removed, is de-shuttered. It's called as de-shuttering. Okay. And once that is there, the lintel itself is very very strong, and it will carry the loads. It will carry the loads. I hope it is now clear what they are doing. First, the brick wall, that is supports, they are going to construct. Yes. Second is what? They are going to put centering. How they are going to put the centering and shuttering? They will put the vertical bamboos like this, and they are going to place a vertical horizontal steel plate like this, and in the side way they are going to put more steel plates. Inside they are going to put the steel bars. Inside they are going to put the steel bars. Stirrups they are going to put. Steel bars means what? Main steel, stirrup steel. Okay. So both are made up of ms bars only. 6 mm dia as well as 8 to 10 mm dia, both diameters can be used. Once everything is fixed, steel bars are placed in place. Okay. And shuttering is correctly done accurately. Proper support work is provided in the form of props, bamboos. Okay. Bottom is sealed down. Later everything is okay. Now concrete is placed inside, and small vibration is given such that concrete is spreaded uniformly, and it is left for 1 day like this. And after 1 day you start curing process. Provide water for the hydration of the cement. Later on, and after the 20 or 21 days, you remove the vertical stirrups, you remove the bottom shuttering work or centering work, as well as side formwork works. Side formworks. So after everything is removed, it is already strong. It is already strong. Later on, you can go for construction of the masonry on the top. So this is reinforced cement concrete lintel. So RCC lintel. Why it is important? RCC lintel means what? Here you can see the bars, no? So in the cross section, if these are dots, I will go for this diagram. In the cross section, if it is a dot or circle, in the main it is like this. It is like this. I hope it is now understood. So top dots are nothing but top main steel. Top main steel. What is this? What is this? Full square. These are nothing but these verticals. These vertical stirrups. These vertical stirrups. Now, if this is a building wall, if it is outside, you can give some more extra bars and get it outside, and you can use it for sunshade. Yes, one side. For the same bars, some hook type of structure is taken inside. Means what? Bars only. You can act as a, what is that? Chajja. It is act as a chajja. So have you seen inside in the kitchen? Kitchen you generally have chajjas. Chajja on the top you generally keep what? Small water cylinders, cans, everything you are going to put, no, which are not much of a use. So that is called as chajja, which is there inside the kitchen or any room. Okay, in halls, in main halls or entry lobby, the chajjas are not there. In bedrooms, kitchens, and other things, the chajjas are provided throughout the room, throughout the periphery of the room, to make utilize the space. And on the top of this chajja, you generally keep the instrument or any home small things. Okay, so outside bar, it is called as this one, sunshade or sunbreaker. Now, so this is a cross section. What is this? Very, very important. What is that? Very, very important. RCC lintel with the chajja projection. Okay. Now in this diagram, it is the inside of the room. It is inside, it is outside. So how they are constructing? This is the reinforcement bar. This is the reinforcement bars. Okay. So they have taken one support bars, and above that again some distribution steel they have provided. Okay, so everything is casted in the concrete. Everything is casted in the concrete. Later on it will give a strong horizontal element. It will strong give horizontal element. On this you keep some small box, small things inside the room, inside your room. So everything is kept here. So this is the cross section of RCC lintel with the chajja projection. Very, 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 very important from the exam point of view. So many times they have asked this question only. Draw the typical RCC lintel with the chajja projection diagram. You have to draw. So this portion is called as chajja. So the bar which is coming from the lintel is called as main steel. On the main steel you have distribution steel. These are called as distribution steel. They are running continuously like this in that side. And this section is called as lintel. So this is called as RCC lintel. These are called as main steel. This is also main steel. This is top main steel. This is bottom main steel, okay, which are horizontal, and this is vertical stirrups. This is vertical stirrups, and everything is concrete. This everything is concrete. Okay. Everything is concrete. Now where I should go? Ah, yes, here only. Okay. So here also you can have the just now we have seen, no. So hmm, you have what? Bars which are cranked up, at the end, and you also have shear stirrups. We are discussing what, these things. This. So this RCC lintel. So horizontal bars, vertical bars. Okay. So vertical bars are called as stirrups.